Hello, welcome back. Today I want to do this standard deviation of a discrete random variable, right? So there is a formula for this, right? There is a formula, and I don't really want to go into details about how to use the formula. Um, I mean, I could wait. Give me a second. Let me find it for you, right? To tell you what the formula is. Okay, so let's continue. Now, I wanted to show you the formula. Now, why do I say the formula? So let's read the question. A construction company is considering submitting bids for two contracts. The company estimates that it has a 20% chance of winning any given bid. Here is the probability distribution of X, which is the number of bids the company wins. So here, looking at table, now X is your random variable, number of bids won, and you have 0 and 1 and 2 because you're submitting two bids. You can have 0 win, you can win 2 out of the 2, or just 1. And you have the probability distribution given to you. So given that mu X, right, the mean, the expected value is zero point 0.4 bits, they ask you to calculate sigma X. So this sigma X is the standard deviation, right? The standard deviation. And this has a formula. This has a formula, and it looks very, very uncomfortable. So it's a summation of xi minus mu divided the whole thing square divided by n. Right, n is the um, population size. Okay, so this is the formula, right, for calculating the standard deviation, which means you have to calculate this one, mean. So, but we will give a mean. So what you needed to do is this. It's a very long about way of try to say what I'm about to show you. So the x value, right, 0, you take 0 minus 0 0.4, which is the mean, right? They tell you that that's the mean. And you square it, and then you add it to what's the next x value? 1. So 1 minus zero point 0.4. And then you square it plus, what's the next value? X value 2 minus zero point 0.4, right? And then square it, and then you divide by, ladies and gentlemen, the population size is 3 in this case, right? And it's 3. Okay, so this is rather tedious. Now, the quickest way to do this, ladies and gentlemen, is to put this in the list one. You've already done this before. And let's clear, stat, edit. So since there are 3 data and I already have my 0, 1, 2, 3 here, I just need to put in the corresponding probability 0.64, 0.32, 0.04. And then go to stat, calc, 1 var stats again, L1, L2. Now check this out. You know where to find the mean, 0.4, right? We were told that the mean expected value is 0.4. Do you know that this is where your standard deviation is? So we need to take that number around to 2 decimal places. So 0.57. Oh, right, it's 0.57, round to 2 decimal places. See how easy that is? We do not need to use the formula. So next question. So Gloria enjoys playing skee ball, an arcade game where players toss a ball so it rolls up a ramp and falls into one of several slots. Each slot is worth a different number of points based on how difficult it is to land the ball in that slot. Gloria only aims at the most difficult slot. Well, of course, which is worth 100 whopping points. But she only has a 10% chance of landing the ball in that slot since it's the most difficult slot, right? So if she misses, her ball will certainly land in the 10-point slot. So that's it when she missed. The table below displays the probability distribution of X, the number of points Gloria scores on a random shot. So scoring a difficult shot, 100 points, right? Only 10% of hitting that shot. And if not, it's 10 points and only 90%. So they give you the mean, right? Because in order to calculate the standard deviation, you need the formula. But we do not need that, do we? We just go to stat, edit, and since it's three data, but we only presented two, so let's clear list one, clear list two, and then go back to list one again, and then put in the values of 100, put in the values of 10. Corresponding probability is 0.1, 10%, and 0.9, 90%. Stat, calc, one bar stats, L1, L2, and the standard deviation is 20. Look, check this out. Mean is 19. Mean is 19. Standard deviation is 27. Okay, so should I do one more? I should do one more. So a patient is sick with a certain infection, maybe COVID, where the treatment involves taking a $20 drug that has a 90% chance of curing the infection. If that drug doesn't work, then the patient takes an $80 drug that is almost guaranteed to cure the infection. So the table below displays the probability distribution of X equals to, which is the total amount of money a randomly selected patient spends on this particular treatment plan. So here, right, the total X is the total amount of money spent. So spending $20 on the drug that has a 90% chance of doing the trick, or $100 because if the drug doesn't work, that means the patient has already bought a $20 drug, and if that doesn't work, has to buy another $80, and 20 plus 80 is $100, and that's only a 10% chance, right? If that drug doesn't work, then the patient takes an $80 drug that is almost guaranteed to cure the infection. Okay, so if you are not in here, you're in here. So given the mean, so go to stat, edit. So two data that I will actually go to put in the $20 and then the $100, and then the corresponding probability is 0.9, then 0.1, and then stat, calc, one bar stats, L1, L2. Right here, 24. Standard deviation is 24. I hope that helps. Let me know if you have any questions. Thank you very much. Bye.